Now let's talk about how to add properties to the character, such as life value, attack, defense, etc. There are 2 attributes set in the unfonced gas plugin. You can also recreate it if you use it in the case. You can add it in the structure of ASC. This is what Lyra project does. I hope the project can be more freely used. So I didn't create an fixed attribute set here. The second method is to find SC in the map, add it in the default attribute. And what I use in the project is ability set as a data asset. It can use the action of game feature to add characters that are corresponding to each other. For example, here is the B character. We find this layer. When it uses this function to send add abilities, it will execute this function. The add abilities here corresponds to the same. The G in the action, G, attribute, ability set will add or apply to the character. The ability set can also manually add and provide the G.E.F and take 2 parameters. In this project, when the weapon is equipped, a ability set will be given. To get some G and apply some G to improve the attribute. When the weapon is released or changed, it will use this take function to clear up. This ability set or hero is what all players need to add. I will leave a comment about it. This is where I add attribute set. In the character data, there is also an ability set. It can add some individual functions and attributes for the character. The most important thing is to give each character different growth points. The G here corresponds to the growth attribute of this character. All attributes are obtained in the line mark. This line mark is the attribute value of the character's corresponding level. The G of this character's growth attribute will hit the special mark. Its effect tag is I need. When the character is in initialized state, ability ready will also add the ability set of the character data. Attribute set number 0 shows that the added abilities of game feature have been successfully added. The IC need of SC here is to check if the effect is applied to the I need function. So, after adding the ability set of the character data, the ability set will return to the ability set. This GG will be saved after the handle is applied. The ability set level is upgraded. Now, we have added the attribute and the number to the character. Next, we will display it in the UI. In the Titan game tag that we created, we will open up the game feature. In the game feature, add_vegetes will add a vegetes as a hard. This gameplay tag is the UI layer that corresponds to the previous bound. That is, it is at the bottom layer. Find this hard vegetes. Here, the layout will use the UI XI and X of the container. In the action below, add_vegetes is added to the gameplay tag container corresponding to it. For example, the UI of this health is added here. Tranquility. I will adjust it first. Let's take a look at the action of this add_vegetes. The code is written in the ARPGA code. The part that it needs to accept is add_vegetes. So, in the ready event of the character, after all the attributes are added and completed, add_vegetes is sent. This hard will create and add it to the screen. Find the health bar and see how to get the character's life value. Here you can see the changes between add_trio_build and max_attribute. When the UI is created, it will use the fender_add_attribute function of the character in the BC_attribute group. It will create an mvo_model for this attribute. Mvo_model is the function that is newly added after 5.2. This group is the UI for gas that I mentioned in the FAV business. After creating it, it is tied to the UI event. So, after changing the attribute every time, it will trigger the corresponding function. Change the value of this progress bar. We are now running the game. Open the menu. There will be other attributes tied here. It is also used in the same way, but it is not the same in terms of performance. Let's zoom in and see the code. The attribute of the attribute_set is convenient. After setting the UI, use fender_at_attribute to find the corresponding vimvo_model, and tie it to the set_value function. After changing the attribute value, it will trigger the set_value function to modify the text. Now, we add a note on the character's head. The general way is to add a widget to the character. Select another widget again. But what I use in the project is a single indicator system. From Lyra to the RG inventory system, open our hard widget. You will see that there is an indicator layer here. It is necessary to display the indicator. Add 3 components to the game feature of RPG. The RG indicator manager will add the player controller. It shows the necessary components of the indicator. Use the RG indicator manager to add the indicator. The indicator will display the indicator on the screen. The indicator on the screen does not only have the indicator on the top, but also has interaction information that will be used to this function. And these two are the main components to create and display the indicator. The source component is added to each character, including the monster. It will send a message to the top component. This component is for the player controller. This will create an indicator for each scene character and display it on the player screen. This is the widget used by indicator. The back shows where it is. Open the display first. Because I don't need to see my head. After running the game, you will see the widget that was just designed on the head. Return it back. Now I put a monster in the scene to see the effect. The operation is only for testing. Create a character with AC of Z and put it into the project content. From the main asset list, you can get a point data, which is the monster data. Just use setPointData. After testing, these will be deleted. After that, I will use MassOwner to create a monster. Now I put the created monster in the scene. This indicator system comes from Lyra. But I made a modification. I added the distance to the depth of the target. Now I put the monster in multiple, and its display will go in from the distance. This design is about the target that is not in the camera angle. In the indicator layer, you can set the arrow. The operation can see the effect. Now I set it to false. After running it again, it will not show after leaving my camera angle.